Growing stars. In this activity, you need to look at the star pattern and answer the questions: what would the next picture in the sequence look like? How is the sequence generated or made? And how many squares will there be in the 10th, 20th or 100th picture in the sequence, and how do you know? Let's break it down and take a closer look. In answering question 1, what would the next picture in the sequence look like, we are also starting to think about how the sequence has been generated. We can identify that one square is added to each arm of the star for each consecutive or following picture in the sequence, which, when drawn out as a sequence, looks like this. In order to answer question 3 of this problem, we need to first take a closer look at question 2 and how the sequence is generated. For this, I am going to use Cuisenaire blocks to illustrate my working, where each coloured block represents a different value between 1 and 10. If you don't have any Cuisenaire blocks of your own, you can click the link below to go to an online version. So, using our Cuisenaire, we can identify that picture 1 is made up of 1 block of 3 and 2 blocks of 1. Picture 2 is made up of 1 block of 5 and 2 blocks of 2. And picture 3 is made up of 1 block of 7 and 2 blocks of 3. We can also make the sequence in a different way. This time, each picture has 1 block of 1 in the centre. Picture 1 then has 4 more blocks of 1 to make each arm of the star. Picture 2 has 4 blocks of 2 to make up each arm of the star. And picture 3 has 4 blocks of 3 to make up each arm of the star. Now we're ready to tackle question 3. We could just draw the sequence all the way up to the 100th picture and count the number of squares in the 10th, 20th and 100th pictures of the sequence, but it would take a very long time and an awful lot of paper. So instead, we're going to calculate the answers by creating one sum which can then be used to work out the number of squares in any picture of the sequence. To do this, we're going to start by just saying what we see and writing it down as a calculation. Here we go. In the first picture, we see it is made up of 2 blocks of 1 and 1 block of 3. In the second, it is made up of 2 blocks of 2 and a 5. And in the third, it is made up of 2 blocks of 3 and a 7. However, with values like 3, 5 and 7, what size block will be needed in this part of the calculation in, say, the 100th picture? Ideally, we need a calculation which can easily be substituted for any picture in the sequence. So, how can we make each of these numbers? Well, we can make 3 with 2 blocks of 1 and then adding another 1. And following this same pattern, we can make 5 with 2 blocks of 2, then adding 1. And finally, we can make 7 with 2 blocks of 3, then adding 1. Nearly there. By writing out our new calculation for each picture, we can see that we now have 2 multiplied by 1, add another 2 multiplied by 1, and then add 1, which we can simplify to 4 times 1 altogether, then adding 1. By writing out the calculations for pictures 2 and 3, we come to the same calculation, only this time substituting 2 and 3 in place of the 1. Looking at the second way we generated the sequence in the same way, and starting by saying what we see, we can see that picture 1 has 1 block of 1 in the middle and 4 blocks of 1 as the arms of the star. Picture 2 has 1 block of 1 and 4 blocks of 2. And picture 3 has 1 block of 1 and 4 blocks of 3. And if we reorder these calculations, we can see that we have come to the same answers as last time, except this time the way we generated each picture made it quicker to do the calculations. So, in order to express a general statement, we need to describe a sequence and explain how it was generated. We also discovered there can be different ways of looking at a sequence, but ultimately we can come to the same general statement. So, all that is left is for us to write our general term where the lowercase or small letter n can be used to replace the number of the picture in the sequence, and a capital N can be used to represent the answer or number of squares in that given picture of the sequence. Now, using our general statement, we can calculate the number of squares in the 10th, 20th and 100th pictures of the sequence, where 4 times 10 add 1 equals 41 squares for the 10th picture. 4 times 20 add 1 equals 81 squares for the 20th picture. And 4 times 100 add 1 equals 401 squares for the 100th picture. In fact, with our general statement, we can now calculate any picture in our sequence.